Problem 1C. For the circuit shown in the figure, find the current through 30 ohms resistor using mesh analysis. This is the given circuit. Here we have 30 ohms and we have to find out the current passing through this 30 ohms resistor here in this circuit. Coming to the solution, first redraw the given circuit. This is the given circuit. Coming to the mesh analysis, first of all we have to identify the basic loops in the given circuit. Here it is 100 volts. Basic loop in the sense a loop which contains at least one new branch or new element. Here first of all I consider this as a basic loop. Here 15 ohms, 20 ohms and 50 volts voltage source are associated to this loop. And if I take another basic loop of this which contains 5 ohms, 30 ohms and 20 ohms, but this 20 ohms is already associated with loop 1. Here 5 ohms and 30 ohms are new to this, then this is a basic loop. Now I consider another basic loop. Here 30 ohms is associated with loop 2 and here 5 ohms and 100 volts voltage source are new to this loop. No other basic loops are here because all the elements which are present in the circuit are associated with the three loops here. And coming to the direction of the each loop, either in clockwise or anti-clockwise direction. Here I assume the direction of the loop currents in clockwise direction and mark the loop currents as I1, I2 and I3. Mesh analysis is the combination of KVL and Ohm's law. Mesh analysis is the combination of KVL and Ohm's law. Okay, first I write the KVL equation for the loop 1. Apply KVL to the loop 1. Here in this loop 1 we have three elements: 15 ohms resistor, 20 ohms resistor and 50 volts voltage source. Here the current direction which is here in this voltage source is from minus to plus. Then it is a potential rise. Take it as plus 50. Next, here we have 15 ohms resistor and 20 ohms resistor. Here while writing the mesh analysis we consider resistance has drop. Then we put minus voltage across this resistor is nothing but 15 into current passing through, that is I1, that is 15 I1. Next, coming to this 20 ohms resistor, it is in between loops 1 and 2. Here the I1 which is from top to bottom here in this 20 ohms resistor, the direction of the I1, and the direction of the I2 here in this 20 ohms resistance is from bottom to top. In the sense I1, this is I1 direction and this is I2 direction. Both are in opposite direction. Then the resultant current which is passing through this 20 ohms resistance is nothing but difference. But here we write the equation for the first loop. So we consider the first loop current is greater among the all other loop currents. So Here I1 is greater than I2 while writing the equation for loop 1. Here it is a resistor. There we have drop. Put minus 20. It is resistance into current passing through, that it is the difference of I1 and I2. We write I1 minus I2 because we write equation for loop 1. We consider loop 1 current is greater than loop 2 current. Then we write I1 minus I2. Next, no other element is connected in here in this loop 1. So put equal to 0. By simplifying this, we get a minus 35 I1 plus 20 I2 is equal to minus 50. This is expression 1. Now apply KVL to the loop 2. Here this is the loop 2. Here we have 3 resistors, 20 ohms, 5 ohms and 30 ohms. Coming to this 5 ohms, it is belongs to second loop only. Then it is a resistor, we have a drop, put minus 5 into I2. Next, coming to this 20 ohms, which is in between I1 and I2, in between two loops, loops 1 and 2. So the current passing through this 20 ohms is a difference of I1 and I2. But here we writing the equation for loop 2. So loop 2 current is greater than the all other loop currents. So minus current passing through this 20 ohms is nothing but I2 minus I1, and it is multiplied by a resistance, we get voltage across this 20 ohms. Next we have another resistance here in the second loop, that is 30 ohms, which is connected between loop 2 and 3. It is a resistor, we have drop, put minus, and it is 30 into I2 minus I3. This 30 ohms is connected between loop 2 and 3. The current passing through 30 ohms is difference of I2 and I3, but we consider I2 is greater than I3 because we write the equation for second loop. Then no other element is here in this second loop, put equal to 0. Now simplify this, minus plus 20 I1 minus 5 minus 25 minus 30 minus 55 I2 plus 30 I3 is equal to 0. Let this is the expression 2. Now apply KVL to the loop 3. Here this is loop 3. Here we have 30 ohms resistor, 5 ohms resistor and 100 volts voltage source. Coming to this 100 volt voltage source, the I3 is traveling from positively marked terminal to negatively marked terminal. So it is a drop. We put minus 100. Next, coming to this 30 ohms, it is connected between loop 2 and loop 3. The current passing through this 30 ohms is difference of I2 and I3. But while writing the equation for the loop 3, we take I3 is greater than I2. So voltage across 30 ohms is okay. It is a resistor. There we have drop. Put minus 30 into I3 minus I2. Next we have one more resistance. This is 5 ohms. Yes, it is a resistor. There we have drop, put minus 5 into current passing through, that is I3, 5 I3. No other element is here, put equal to 0. Now by simplifying this, we get 30 I2 minus 35 I3 is equal to 100. This is expression 3. Here mesh analysis is the combination of KVL and Ohm's law. KVL plus Ohm's law. What KVL says? Algebraic sum of voltages in a loop is equal to 0, and that voltage is expressed in terms of I and R. That is, with the help of Ohm's law, we write voltages as I into R form. So this mesh analysis is the combination of KVL and Ohm's law. Now by solving these three equations, we get I1, I2, I3. Switch on, press mode, equation 5. Here we have three equations and three variables. We have to select option 2. Then enter first equation. First I1 coefficient minus 35 equal to, next 20. There is no I3 coefficient, 0, and minus 50 constant. Next, coming to the second equation, 20 is the I1 coefficient and I2 coefficient minus 55, I3 coefficient 30, and there is no constant, enter 0. Next, coming to equation 3, here I1 coefficient is 0, enter 0, I2 coefficient is 30, I3 coefficient is minus 35, and constant is equal to 100, and then plus equal to, we get x is equal to minus 2 by 5 plus st, we get x in the sense here I1 is equal to minus 0.4 amperes. Next, plus equal to, we get y is equal to minus 16 by 5 plus st, we get y is nothing but I2 is equal to minus 3.2 amperes. Next, plus equal to, we get z is equal to minus 28 by 5 plus sd, we get z is nothing but I3 is equal to minus 5.6 amperes. Coming to the question, we have to find out the current passing through 30 ohms resistor. Here this is the 30 ohms and we have to find out the current passing through this 30 ohms resistor. Here this 30 ohms is between loop 2 and 3, and the current passing through this 30 ohms is nothing but difference of current I2 and I3. So current passing through 30 ohms is nothing but I2 difference I3, that is I2 minus 3.2 minus of minus plus 5.6, that is equal to 2.4 amperes. This is the required answer. Current passing through 30 ohms. This is the required answer. It is 2.4 amperes.